Assalamu alaikum. Good afternoon, all. Just now I got introduced by Chris that my name is Takahashi. I'm responsible for the digital enterprise business in Yokogawa, Middle East and Africa. Thank you so much for coming and joining this webinar where we will discuss about introduction to Yokogawa Digital Transformation, including Q&As. For me to go through the presentation, let me turn off my camera to optimize bandwidth. Give me a moment, please. Here. Okay, I hope everyone is seeing the screen as a presentation. So this is today's agenda. First, I would like to introduce myself, followed by a very brief introduction about Yokogawa in Middle East. Then followed by industrial automation to industrial autonomy concept, which is Yokogawa's digital transformation direction to support our customers' digital transformation journey. Then followed by, I'd like to introduce some use cases about digital technology. Then, as a conclusion, we will discuss about how to start the digital transformation journey together with the customer. Then we will have a Q&A time. Okay, then let me briefly introduce myself. My name is Takahashi. I'm responsible for the Digital Enterprise Business Division, which is belonging to Process Solution Business Unit under Yokogawa Middle East and Africa. I'm based in Bahrain. I joined Yokogawa in 1996 as a software developer for our control system, then moved to the level 3 solutions like MES or MOM type of solutions. Then I came to Middle East in 2018 for the process solution sales. Then last year, I started my new role as a digital enterprise business. This is my brief introduction. Then, yes, then this slide explains the Yokogawa Middle East business operations and the Middle East and Egypt countries. So we have our headquarter, regional headquarter in Bahrain, Yokogawa Middle East and Africa. Then we have multiple business operations under Middle East countries, like we have offices in Saudi Arabia, also another office under Saudi for the service in Jubail. We have office in Qatar and the UAE and Oman as well. And we also have a service and engineering center in some countries like UAE and Yanbu in Saudi Arabia, Egypt, and Kuwait. So this is our Middle East business operations introduction. Okay, then let me start the main topic about digital transformation. The topic is about industrial automation to industrial autonomy. So we all are facing the emerging challenges like such as changing the business environment or the value chain visibility and optimization of sustainability. And the latest and the biggest challenges which we are facing now is how to deal with the COVID-19 pandemic. This has given us not only for our day-to-day work, but it has completely changed our way of working, including not only the office, but also your production facilities as well. So in this challenging environment, how digital technologies can help improve your day-to-day operation. That's the challenge. So to address those challenges, the process industry needs to evolve. Then how to evolve? What's the target to achieve through digital transformation? The answer is towards autonomous operations. Yokogawa's direction to support our customers' digital transformation is towards industrial autonomy. Currently, all companies are at some stage of automated operations as a starting point. IA to IA, which stands on industrial automation to industrial autonomy, is what Yokogawa foresees as that transition from automation to autonomy world. So we define IA to IA as plant assets and operations have learning and adaptive capabilities that allow responses with minimal human interaction, empowering operators to perform higher level optimization tasks. As many digital technologies are being developed and released into our market, the process industry is in a big movement from automated operation to autonomous operation. Then, what is the difference between automation and autonomy? So, the above picture shows how the automation world is. So there are some automated tasks already implemented in your production facility or plant. However, to start or to select what are the procedures or tasks to be executed in time by time, the decision is made by human, means human intervention between sequences of tasks. So the human starts the automated task. Then once the automated task series of tasks are completed, then human will again come into picture, understand the current situation, then decide the next action. However, when we transform to autonomy world, then some of or all of those decision making currently made by human will be done by the intelligence. That is the difference between automation and autonomy. And this illustrates Yokogawa today. So Yokogawa has been well known as automation technology supplier. However, to support our customers' digital transformation better, Yokogawa acquired KBC Advanced Technologies together with Industrial Knowledge and Soteka Visual Mesa in year 2016. KBC has a leading simulation technology for hydrocarbon industry together with strategic consulting expertise. Industrial Knowledge has secure cloud services which enables supplier and customer secure collaboration. Soteka Visual Mesa has digital energy management and optimization solution, as well as digital supply chain scheduling and accounting solutions. By this M&A, Yokogawa's solution portfolio to achieve our customers' digital transformation journey has been extended, and we are continuing to engage with other technology suppliers, for example, robotics, etc., to obtain further necessary technologies. So what is the driver for the digital transformation? This illustrates the value brought by digital transformation. Efficiency to achieve maximum profitability, safety and security to prevent accidents, injuries, or incidents. Higher availability and reliability by eliminating downtime with resilient, reliable, and self-healing assets. In addition to those main drivers, of course, improved human reliability is also the key for our industry, because human is the one who is running the plant day by day. In addition to that, the transformation can further address challenges by changing business environment and optimizing supply chain. Also, as it is being discussed under SDGs, sustainability and circular economy is getting focused not only by industry, but also by human ourselves. Yes, even there is a driver and there is a need to bring those digital technologies into our industry. However, we need to consider new requirement for autonomous operations because we will more rely on those technologies. So higher levels of autonomy needs more stringent requirements. For example, in IT area, like we need to bring advanced analytics technology, big data, artificial intelligence or machine learning or deep learning, etc. And the technology must be bulletproof in terms of hardware and software systems. And smarter devices or even autonomous devices is demanded. And cloud and edge devices are getting available in the market. When we see on the OT side, there are technologies like advanced process control, optimization, procedural automation, digital twins. Those are existing, but we shall consider to integrate those things for the digital transformation journey. In addition to that, there are new technologies like robotics or more sensors like IIoT devices. Those are the key technologies. And also, we need to consider the greater control and the resiliency and flexibility, adaptability, and also interoperability is required because from now onwards, not just bringing the single technology, but integration is also the key towards the success. I will talk about this in a later slide. And these are the key enablers and drivers for the digital transformation. As we have discussed, or I've talked, many technologies are being developed and coming in the market. Cloud is getting very familiar and popular in the industry. Data analytics technology, IoT or IIoT platforms, digital twins, smart sensors, 5G technologies, AI, cognition, blockchain, augmented reality, virtual reality, or mixed reality, together with wearable devices, modularization, 3D printing, robotics technology. So those are the key enablers for the digital transformation in our industry. And how would the digital transformation journey look like? Yokogawa's strategic direction is to support company, our customers, in transforming towards autonomous operation. So this slide explains a typical phase-wise approach that we used to support this digital transformation initiatives. We believe the journey doesn't complete by just bringing those digital technologies, but it requires alignment with the company's digital transformation vision and objective. Also, it requires change management concept to transform people mindset because people is the one who use those technologies to achieve the transformation. So till now, I have talked about the market challenges and Yokogawa's direction towards digital transformation. Then from now onwards, I would like to introduce some use cases, technology use cases for the digital transformation. The first topic is about digital shift team management. This is a study made by NPRA in 2009 that the plant incidents, total plant incidents out of total plant incidents, 40% of those incidents are somehow related to handover activity. However, on the other hand, when we see the shift team time consumption ratio. They can spend only 5% of their working time for handover activity, which means this 5% time is very critical to hand over the correct information to the incoming shift to reduce the incidents or accidents related to handover. Why this happens? We understand that in the shift activity, there are so many manual tasks relying on analog information, like managing the data on the papers or the whiteboard, the telephone communication, etc. Because of which data is inaccessible and difficult to share among people, which also leads to the difficulty to make the governance. Then from the management point of view, it's difficult to get the insight that what's happening in the shift or day-to-day shift operations because the data is not digitized. That's why we brought this digital shift management solution for your shift groups. So when you have a shift team, you have a shift supervisor, operation manager, you have operator, board operator, field operator. So those multiple roles of people are working in one shift with sharing the necessary data at necessary time. However, those data is scattered many places. That's why they have challenges to have a common information or correct information at the necessary time. So by digitalizing those shift team activities, then they can we can build a central workplace for the shift team to access whatever necessary data for his operation from this single window. Then at the end, because they are working in the single place, so the handover from the outgoing shift team to incoming shift team will also be smooth because all the data is integrated into this single place. And this, of course, appreciate the existing systems, like when we see the enterprise level, you have ERP or you have a document management system, etc. On the other hand, when we see the plant shop floor, you have laboratory information management system, you have plant historian, you have handheld inspection. So having this single window together with the integration to those existing systems, we can bring all the necessary information into the single window. So this is the digital shift management concept. To extend further, we are also having a technology to digitalize the field operation. So by using those tablet devices, X-certified devices, or those smart wearable devices on the helmet, we can digitize the field activities as well, so that in addition to for field operator to record his inspection result on the paper and coming back to the control room and transcript it into Excel file or whatever other information database, this can instantly digitize the data at field, then further utilize that data. By this way, your shift team will be fully digitized, then all the necessary data can come in a single place. Okay, the next topic is about robotics. So robots and drones. So robots can be used for unmanned facility. There are many types of robots available in the market. And nowadays, 4G or 5G, the faster communication method is getting available. So we can get the data from robots in the remote and safe area. So this can reduce the exposure of your people, the human resource, to such a hazardous environment. And drone could be used for line or pylon inspection. So we decide the asset to be inspected, then find the open areas with a clear view of inspection, and then plan the flight beforehand. So it can help capturing the data of the site and send photos or videos feed detailing the problematic areas to the team responsible. So the data which is captured and sent by those robotics technologies can be further utilized for the analytics. So we can here bring the artificial intelligence technology into here so that the video or the photo of the analog gauge in the field can be digitized automatically by AI for the image recognition. Then we can record it as a trend, and we can further analyze the trend for getting some predicted prediction of the issues. Or like drone can be used for the corrosion monitoring of the pipeline. Also can be done by the image recognition technology. Seems I'm getting some issues. Am I still audible?
Yes, Takashi.
Sure.
Yes.
Sorry, my PowerPoint got a problem. My apology for this problem. There is a technical issue. Let me reopen my presentation. I will come back shortly. My apology for this technical error. I was here on this slide. Yes. So in the market, there are many types of robots available, like this type of four legs robots, or this type of crawler types of robot, or drone technologies as well. So based on the use cases or the requirements to apply the robotics technologies, we shall select the suitable robot technology, then implement. Yokogawa has been working with X Robotics as a robot technology partner, and there is a reference cases in the Shell refinery in the Netherlands. Like this is the robot technology from X Robotics company, and this has a camera on it, and also we can configure multiple sensors on the robot itself. So sensors are available for H2S gases or the hydrocarbon gases or etc. So based on the need, we can configure the robot to mount the necessary sensors on as a payload on the payload. Then we deploy this robot into the field. And one important thing is Yokogawa is not the robot technology supplier, but we are the party to integrate multiple and existing robotics technologies into your control systems and your industrial automation systems. So we are developing and delivering the middle layer to integrate those multiple robot technologies into your IA systems. The next topic is about the data analytics technology. So a challenge for the plant availability improvement. So as is currently, the plant maintenance is like a breakdown maintenance or time-based maintenance. And the board operation is a kind of reactive operation based on alarms. And individual skills, relying on the individual skills and experiences. However, we want to move or bring this up to proactive ways so that we will achieve the preventive maintenance or the condition-based maintenance. Also, the operation style will change to a predictive type of operation. So Yokogawa has an AI technology to predict the abnormality of our customers' challenges. So customer has process data and operational data and process operation knowledge. And Yokogawa has data analytics technology and also data analytics algorithms. And we have a system for the measurement and controls. So by getting those data, including the IIoT sensor, and combining those knowledge and technologies together, we can develop a machine learning model which generates the healthy index like this way, so that the machine learning model can predict certain issues in advance. Then the plant operation team can run or take the corrective or recovery action before the issue happens. Let me just briefly introduce how our Yokogawa's IIoT sensor look like. We named it as sushi sensor because the size and the shape looks like Japanese sushi. But you can see that this is an example of the rotating equipment. Then we can mount the sensor very handy because this can be mounted by screw or mounted by a magnet. Then it uses a LoRaWAN wireless communication protocol. Then the data can be easily integrated into the central place. Then we can run the AI algorithm to predict the rotating equipment failure. So of course, we understand that your critical equipment or level 1 critical equipment already have such analytics technology. However, your field operator is doing the inspection round to check the sound as well as the vibration for those next level importance rotating equipments as well. So such activity can be supported by this type of IIoT sensor or together with the robot technology so that we can further digitize and make the efficiency better. On top of AI algorithms, by utilizing the modular procedural automation technology, we can prepare the logic to or a procedure to react such certain situations. So modular procedural automation technology is can help to automate certain manual procedures currently executed by your board operator, so that once the machine learning predicts a certain condition, then we can trigger the corrective action by this procedural automation technology. Then the human intervention to recover from such situation can be minimized. So by combining those things, we this illustrates the AI embedded digital advisory system. So in your daily operation data is stored in the data source as a historian. Then we can build a digital twin model, the process model of your actual plant. then we can run the machine learning model on top of this data. Once the issue is predicted, then your subject matter experts can utilize a digital twin model to analyze a way to recover from that situation, or if the issue is not critical case, then we can automatically trigger such a modular procedural automation solution, or we can further instruct cobot, stands-on collaboration robot to take further action in the field. Next topic is the virtual reality use case. So it talks about asset digital twin. So in the current situation, for your field operator or maintenance technicians to understand your asset situation, there is a limit, physical limitation, like he needs to go to the field itself and then he needs to work. However, for example, inside the equipment, he cannot see if the equipment is running. But when we build a virtual model of your asset, then such challenges can be addressed. So what we will do is we will build a 3D virtual plant that can be operated and monitored. Then we can execute a virtual reality training to memorize as a real experience by operating devices in a virtual space. Then your people, your team can experience anytime and many times work or events that cannot be done easily or rarely occur in the actual field. How it looks like is this. What you are seeing here is all virtual reality models example. So in the virtual reality glass, he's seeing that this valve, manual valve is just in front of him. And then he can move, open, close this valve. Then behind we have process simulation models so that this manual action can be propagated into the process model. Then other automated equipment or the transmitters will work as a real process. On the left-hand side, you see that this is the furnace model. Then if it's working, then we cannot open or we cannot see inside. However, in the virtual reality model, we can achieve this kind of training also. So this can be further utilized for the confined space work training, etc. So once we bring the virtual reality and the process simulation modeling technology, these can be the considered applications or use cases for those technologies. 3D digital twin, integration to plant documents, then it can be used for training tool, which can be integrated into OTS. It can be a repository of plant asset data, integration to live plant data. We can further integrate such virtual reality model to the field data, like a maintenance plan, a maintenance activity, permit to work, or MOCs. So once you build the model, asset digital twin model, then this model can be utilized for multiple use cases or objectives. So this is my last technology use cases, that is enterprise level integration. So what is the drive for the digitalization? There are multiple different roles and organizations in your enterprise, like a maintenance team, operations team, HSE team, technical service team, finance, or those management teams. And they all have different activities and objectives and also challenges. Then, yes, the digital technology can be introduced, adopted into those different purposes. However, at the end, integrating them in the enterprise level is also important for them to see the different data from different sources, but in a synchronized and correct way. We call it as a single version of truth. So by integrating those multiple technologies and solutions, they will see a different set of data, but the truth is only one. So this is the image of the enterprise integration. So as you are seeing as a jigsaw puzzle, there are many technologies and solutions already available in your plant as well as in your enterprise. However, there are some challenges like to integrate those different technologies into one. So what we are supporting is this layer, the yellow color layer, as integrated management system, which supports integration of different and various systems, as you can see in this picture. Right. So those are the technology use cases of digital transformation. Of course, it's not limited to those only. Today I picked up some key technologies which can contribute the digital transformation. However, like as I said in the earlier slide, that just bringing the technology would not work. So how we Yokogawa to support our customers' digital transformation journey is explained in this section. So Yokogawa's approach for the company customers' digitalization journey is illustrated in this page. So we would like to see where that particular customer or company is. So that we call as a readiness review. Because different company may be sitting at different level of adoption of digital technology. So we first need to understand where your company is and where you want to go. And after that, prerequisite readiness survey is done. Then situational awareness for us to implement low-hanging fruits to start seeing the ROI, which is more on the prioritization of the implementation of the technology. Then we will come to the operational execution stage, where we implement the operational execution improvement tools based on the benefit analysis to improve overall capital and asset efficiency. Then once that implementation is over, then it's not the goal because we need to keep monitoring how the technology adoption level is and if that technology is working properly or not. That phase we call it as a value sustainment. So in one level deep, how we will approach is described in this page. That is the methodology of the digital transformation. Yes. So our approach and the way forward for the digital transformation journey is the first step is a digitalization vision workshop, where we would like to understand from company's senior management about the vision of the future and how digitalization fits in this. And the expected outcome from this digitalization workshop is, after that, what is the company's expected outcome from digitalization and its impact on company. Then we will proceed for the opportunity identification phase. So based on the vision workshop, Yokogawa will start studying the detail from company to identify opportunities for the digitalization. Followed by opportunity evaluation. Once we identify the opportunity, then we will evaluate together with company that how how much those opportunities can bring value to a company, and so yeah, such analysis will be made. Then followed by opportunity prioritization, where based on the analysis of the identification and evaluation, and also the input from the senior management, we will prioritize which technology in which area has the priority to start. Then after that, we will do the readiness assessment, like we will study where your current operation is. And then this is the goal. So what is the gap we can understand? Then we can define the implementation plan. Then as a result of this workshop and study, we will develop a digitalization roadmap which shall suit or meeting with companies' digital transformation direction as well as a goal. Then we will submit the opportunity and benefit study report. So this is the overview of our digital transformation workshop methodology. Yes, now I am coming to the concluding remarks. So the digital transformation journey provides below benefits like optimizing the assets with the real-time data and faster decision making, anticipate equipment failures and improve asset integrity and availability with predictive maintenance. We can help to mitigate risk and prevent HSE incidents and improve the security and environmental protection. Increase agility, reduce inventory, and balance supply and demand through supply chain optimization. Reduce operational expenditure per barrel produced with data-driven management. Reduce capital expenditure by optimizing asset lifecycle cost using 3D virtual reality or mirror plant. And support knowledge sharing and personal welfare with wireless connectivity. So those are the benefits or the driver or motivation for you, company, to proceed towards digital transformation. Then this is my last slide. So again, Yokogawa's approach to digital transformation is to define the problem or define the cause of the problem, because digitalization and or technology can solve significant problems for operating companies. In order to truly deliver value, Yokogawa starts by listing out various factors identified by company and works to identify the cost of the problem to company. This gives a clear picture of what is happening. Then identify the solution. Once the issues are identified and their impact is analyzed, it is easy to draw out a roadmap of what issues need to be addressed first and how. This provides a clear roadmap for the future. And of course, the return on investment is a key factor for company to decide if you will proceed for that implementation or not. So a good digitalization implementation is one that can pay for itself. The roadmap is built keeping this in mind, addressing all the low-hanging fruits first with maximum impact and moving up. This approach not only delivers an excellent digitalized field, but also ensures that there is value to company in what way, and when, and how it is done. So at the end, clearly, the thing that's transforming is not the technology. The technology is transforming you. This is my last slide of the presentation. Thank you so much for your attention.